Assalamualaikum and good day everyone. So we meet again. We will continue with learning outcome 13.2c, solve problem related to root mean square, speed of a gas molecule. Okay. And first and foremost, you need to know that the root mean square, sometimes we are going to use uh, root mean square. Okay, so the symbol would be VRMS. Okay, so this is the symbol for root mean square speed. So let's go to the first question. 8 gas molecules chosen at random are found to have speeds of 1, 1, 2, 2, 2, 3, 4, and 5 meters per second. Determine the mean speed of the molecules. Okay, now what is the symbol for mean speed of the molecule? Okay, so the symbol for mean speed is actually this. Okay, so this is the symbol for mean speed. So the formula for the mean speed is actually the summation of that particular speed. So if we have 10 molecules, we have to put here the speed of each of the molecules. Okay, so that will be n. Let's put here I integer equals to 1 divided by number of molecules. So for this case, we have a speed of 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 5. Okay, divided by number of molecules given here. The number of molecules, there are total of 8 molecules, so divided by 8. So your mean speed would be, first your calculator. Okay, always use the calculator. So 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 5 divided by 8, and your answer would be 2.5 meters per second. Okay, so that is the mean speed of the molecule. So now let's move on to part B. Okay, so for part B, they ask you what is the mean square speed of the molecule. So now they ask you the mean square speed. Okay, so what is the symbol for mean square speed? So basically, just square it. Okay, mean square speed. Okay, so that would be the summation of each of the speed. You square it off. Okay, so divided by r equals to 1 by number of molecules. So for this case, we have 1 square plus 1 square plus 2 square plus 2 square plus 2 square plus 3 square plus 4 square plus 5 square. Okay, and divided by number of molecule, which is also 8. Okay, your answer should be 8 meter square per second square. Okay, so that is 8 meters square per second square, because they ask you what is the mean square speed. So basically, you have to square each of the speed and find the total of the square of the speed. Okay, so next would be find the root mean square speed of the molecule. Okay, most important part is you need to know what is the symbol of root mean square speed. So the root mean square speed is VRMS, and the formula is uh you just square the mean square speed. Okay, so that will be root of v square. Okay, so square root of 8 would be 2.83 meters per second. So that is the root mean square speed of the molecule. So that is how you do question number 1 for exercise 2. So next, let's continue with question number 2. Okay, let's continue with question number 2. So for question number 2, a cylinder of volume 0.08 meter cube. So this is the volume of the cylinder, 0.08 meter cube, contains oxygen at temperature 280 Kelvin and pressure of 90 kilopascal. Okay, given that R is 8.31 joules per mole per Kelvin and K is 1.38 times 10 to the power of negative 23 joules per Kelvin. Molar mass of oxygen is given 32 grams per mole. Okay. Next would be the Avogadro constant also is given. Okay, so first they ask you determine the mass of oxygen in the cylinder. So to determine the mass of oxygen in the cylinder, what we can use is we can use the formula PV equals to nRT, okay, because the pressure is given, the volume is given, R is given, and we have the temperature. So they ask you the mass of this oxygen. Okay, so we need to find the relationship between N and mass. Okay, so that would be N equals to mass over molar mass. Okay, so we are going to substitute the new formula M R T T V. Next, substitute the value given. So we have 90 kilopascal, so times 10 to the power of 3. The volume is 0.08. Don't forget to convert everything to SI units. Okay, it's very important. So we want to find the mass of oxygen. So the molar mass is given, which is 0.032. Okay, so this one is given in gram per mole. Make sure you convert to SI unit to kg per mole. Okay, so R is given, which is 8.31, and the temperature is given 280 Kelvin. Okay, so if you do the math, okay, you should get the mass for the oxygen is 9.9 times 10 to the power of negative 2 kg. So that is for part A. For part B, the number of oxygen molecules in the cylinder. Okay, so for this case, we need to find a relationship between the molar mass, the mass. Okay, we have the Avogadro constant, so we want to find the number of oxygen. So number of oxygen. So that would be capital letter N, number of oxygen. Okay, so for the number of oxygen, we know that N, small letter N equals to mass over molar mass, which is also equals to number of molecules divided by Avogadro constant. Okay, so that would be, you want to make N as a subject. So N equals to M over M. This is capital letter M. Okay, the multiply with the Avogadro constant. Let us continue here. So the mass is, we have obtained it earlier, which is 9.9 times 10 to the power of negative 2 divided by the molar mass. Molar mass of oxygen is 0.032. Okay, again, you need to convert it to kg. The one given is gram per mole. So multiply with the Avogadro constant, which is 6.02 times 10 to the power of 23. Okay, so your answer would be number of molecules is 1.68 times 10 to the power of 24 molecules, or you can say oxygen molecules. So that's a lot of oxygen molecules in the cylinder. Okay, next for part B. Okay, the root mean square speed of the oxygen molecules in the cylinder. Okay, so the formula, you know that the VRMS equals to square root 3RT over M. It's very important for you to know the symbol and the formula. So just substitute R is 8.31. The temperature is 280 divided by M, which is 0.032. Okay, square root. Don't forget the square root because they ask you this root mean square. So that would be 467 meters per second. So that is for part C. Okay, for question number 3, I want you to try to do it on your own and post your answer in Google Classroom. Okay, so we are going to continue with question number 4. Okay, for question number 4, a speed of air molecules. Uh, what is the RMS speed of air molecules O2 and N2 at room temperature of 20 degrees Celsius? I am pretty sure that is not in Malaysia. Okay, given that molar mass of oxygen gas is 32 gram per mole and the molar mass of a nitrogen gas is 28 gram per mole. Okay, so maybe this is the room temperature, the air conditioned room temperature. I'm pretty sure that is not our lab. Okay, so let's try to do the question. So basically, they just ask you what is the RMS speed of air molecule. So we are going to start with the symbol of VRMS. So now, so they ask it separately actually. So they ask for the O2 and N2, the nitrogen and the oxygen gas. Okay, so that will be square root 3RT over M. Very easy question. So that is 3R is 8.31. Okay. The temperature is in degrees Celsius. You have to convert that to Kelvin. So we are going to add 273. Okay. Okay, for the value, sometimes we use 273.5. It depends on the list of constant given in the exam. Okay. So if you have any uh, constant values given in the questions, okay, don't simply write it out even though you know it. Okay, please refer to the list of constant given during exam. Okay, so that would be 0.032 because again this is in gram, you need to convert that to kg. Okay, so don't forget to square root to find your answer. So press your calculator, do the math, and you should get 477.77 and the unit is meters per second. So for second part, so not actually second part, the second one, okay, which is the nitrogen and 2. So PRMS, again, we are going to use the same formula, PRT, 3RT over M, okay. So substitute 3R is 8.31. So 20 plus 273, because we want to convert to Kelvin, and the molar mass of a nitrogen gas is 0.028. Okay, don't forget to convert this to kg. Okay, so should be your answer should be 510.76 meters per second. Okay, so that is how you do it. So that is for learning outcome 13.2C. So thank you very much, class. I'll see you guys in the next video for the next learning outcome. Assalamualaikum warahmatullahi taala wabarakatuh.